In this example, we're going to find the number of terms in an arithmetic series. So how many terms must be added in an arithmetic sequence or series whose first term is 78 and whose common difference is -4 to obtain a sum of 702. So we have our two formulas here that we can use to find the sum. However, we are given the sum now. So I know S of n is 702. I know my first term is 78. My last term is unknown. And I can't find it because I don't know how many terms there are. But I do know my common difference is -4. And so looking at my two equations, since I'll never be able to know the last term without knowing the number of terms, I must use equation 3. And so we now know that the sum of 702 must be equal to n over 2 times our first term, which is 78, plus n minus 1 times -4. And so we have this equation that we need to solve for n. So let's simplify it. I'm going to multiply both sides by 2. And so here I need to distribute the n inside here. And combining the 156 with the 4, I get 160n minus 4n squared. And remember, the sum is a quadratic function. So therefore, we have to use our methods for solving quadratic functions. So I'm going to get everything set equal to 0, and I'm going to make sure my leading term, my n squared term, is positive. So I'm going to bring everything to the left-hand side. 4n squared minus 160n plus 1404 is equal to 0. So we have to be able to solve a quadratic without any thinking. So go back to your integrated 2 and think about what methods you learned. And so you can factor or you can use quadratic formula. So I noticed that 4, 160, and 1404 all have a common factor of 4. So I'm going to divide that out to start, just to make my number smaller. So I get n squared minus 40n plus 351 equals 0. And so I know this has to be factorable. Why? Because our n must be a positive integer. And so I know that it's factorable. Now, 351 is a very large number. I do not know the factors of 351, so I'm not going to factor. I'm going to use the quadratic formula. I have a calculator to use, so I'm going to type in my quadratic formula here. So n is going to equal the opposite of -40 plus or minus the square root of -40 squared plus 4 times 1 times 351 all over 2. And we're going to get two answers here. We get n equals 13 or 27. And both of these answers work in this case. They are both positive integers. And so we get two answers. Sometimes you only get one answer because one of these values will be negative or it may not be a whole number. But in this case, we actually get two. The reason for it is we're adding positive numbers, but our common difference is negative. So we're adding positive numbers for a while. So if I add up the first 13 of these numbers, I will reach 702. And then I continue adding numbers, but eventually the numbers I add turn negative. And so I'm subtracting numbers. And so when I do that for the first 27, I'm going to go back down to 702. And so in this case, there are two answers, 13 and 27.